Just changed my name recently, and I'm trying out with Bantu. That's my name. You know what I'm saying? So let's get started. I don't want to waste your time. So listen, man. This is a challenge right here. I got like 100 questions right here. Okay, we got podcasts in Africa sometime. You know what I'm saying? But I'll try to do my best. You know, if you got to find favorite files, so I'll do all these questions. You know, I'm trying to do all these questions as fast as I can. Okay, so I'll try to do the best I can so I can save a lot of time, quicker, faster, with accuracy. Let's go. I think 100 questions. I want to solve all of them in 30 minutes or 45 minutes. I'll see how fast I can go. Okay, so I'll try to go. That's what I'm trying to talk fast so I can try to save the time. Okay, so I'll try to solve all this question here. You see, there's a lot of question here. This is just a few that I just wrote on a whiteboard, but I got a lot of question here. Okay, so I'll try to go fast as okay. So catch up with me. And another thing was I'll try to explain all the concepts just in case some people are new. They don't say integration, so I'll try to explain all these concepts with the fastest in several lot of time. Let's get started. No waste of time. Let's go. This is a question right here. Okay, so this is the first question here. So let me start with the first question quick. Okay. So the first question is say. So we start now, right? 1. Okay. So they give us integral. So cot. So first I'm going to break that one. So it's going to be cot square x, and let's say cot. This should be 3x. So it's not 3x, and this is going to be cot 3x dx. So another thing I'll do. Look. If you have a code, look, I'll show you first quick. Somebody give you, let's say, this code, you see me say cosec 3x minus 1. That's the meaning of this. And then here we got cot 3x dx. How do I know that? Look, if you have a sign from identity tree, then 3x plus cos x square equal to 1. Everybody knows it. Okay, so if you want to get cosec, for example, here, look, you want to change cot to cosec. Look, so how I'm going to do here, look, I'll divide by sine throughout. Sine square divided by sine square divided by sine square for each individual. So sine equal to 1 plus cos divided by sine equal to cos divided by sine equal to tan. Okay, this can be tan. No, cot. So cos divided by sine equal to cot square x, and 1 divided by sine equal to cosec. You see what I'm saying? So if you want to change, so this is going to help me change cosec and cot all the time. You know, some people they memorize, but most of the time I don't memorize, I prove from there. So for that case now, if I want to replace cot square with a cosec, so I don't want this. So if I don't want this can go over. So cot square x equal to cosec square x minus 1. You see that? Minus 1. So for that case now, look. This is why here, instead of say cot square 3x, I'll say instead of say this cot square 3x, see this cot square 3x, so cot square 3x equal to cosec square 3x. Can you see? Minus 1. That's just the cot square. But I knew from the head, just in case if you knew, that's how you get it. Now, we go. So if I come here, and then I'll take this and multiply in. So integral of cosec square 3x multiplied by cot 3x minus multiply this is going to be cot 3x dx. So bracket, open the bracket, so integral, or I can just multiply, open the first one, then open it with the second one, because we multiply for the first one, multiply for the second one. So the next thing is, look, when you integrate cot is a ln, so this is going to give us ln of sine of this one here. But don't forget outside of here. Not, if you integrate, it's cot, right? So I might get cot f of x dx. When you integrate this is 1 over differentiate this fx, you go f prime, and then here's going to be ln absolute of sine f of x. You see what I'm saying? So that's how you do. Okay, so you take 1 and then you derivate this one, and they say ln of this becomes sine. Remember, you must differentiate this one. So for that case now here, I'm going to say you must differentiate 3x. It's going to be 1 over differential of 3x is going to give us 3. Ln of sine, this is going to be 3x plus constant, because we don't have a limit. Now you come here. So here, what I want to do, I can treat it separately. Okay, so I can let here, remember there's a dx here. Okay, so I can just let, because I know if I differentiate cot, it's going to give me cosec. So I'm going to say let's say u equal to cot 3x. If I differentiate, this is going to give you, when you differentiate means you must differentiate the function, which is going to give you 3. When you differentiate cot, you get cosec. You get negative cosec square 3x for this case, or function. So for that case now, you see what I'm saying? So for that case, just go to differentiation table, and then you should find this. So when you differentiate cot, you're going to get negative cosec, but remember you must differentiate the function. When you differentiate 3x, you get 3, and then you got cosec square. It's cosec square. For example, if somebody give you, I think you know this one, right? Go to differentiating table, you should be able to find this one. But remember, you must differentiate this, and then answer you must write it there back for differentiate. For integration, right underneath, like how we did here underneath. So what you want to get here, look. So now, look, this cos 3x and dx, and cos square 3x, we know. So must divide by negative 3, divide by negative 3. This and this cancel. So cos square 3x equal to, now equal to du over negative 3. Okay, so now I'm going to replace here. I'll say this is equal to, so I can just erase somewhere here. Okay, so I don't need this. So I got all the questions, so I can just erase here because I got all these questions here. Try to make a space here, okay? Okay, so now this is going to be integral, okay? I can just do here, so this is going to be integral. Okay, instead of say cosec dx, cosec square dx, cosec square dx, I'll say du over negative 3. So I'll say du, negative 3 can go to the back, 1 over negative 3. 1 over negative 3 can go because the constant behind integral. It goes behind integral, okay? So got du. And the one more left, I'm going to left you the cot 3x. So let's cot 3x equal to u. So equal to u, so this could be u. You see what I'm saying? And then here we have a 1 over 3, and we have a long absolute sine 3x, and then plus c. Never mind. Thought about that's one you gotta go. Okay, so now this is negative 1 over 3. When you differentiate this, remember this power 1 is going to be u square over 2. Okay, minus 1. That's a power rule of differentiation. If somebody give you integral of x dx, this means power 1. So if it's only this one, means you take this one, add by 1, it's going to be 1 plus 1 equal 2 over, same thing right underneath, and the u plus constant. So the same here, the same thing. So power 1 means is u square over 2. So this going to be equal to, okay, negative u, this will be square, right? Square over 6, but you don't write u anymore, you know the value for u. Whatever if you're cot of 3x, so this going to be cot 3x square. Square of 3x square, and then we minus 1 over 3, 1 over 3, 1 over 3, and then ln sine 3x plus constant. So now it's finished. You see what I'm saying? So final answer here equal to negative 1 over, so when you integrate all this stuff here, I'm not supposed to all these steps, but I'm just doing just for in case for some people who are new, they don't know like the integration stuff, but otherwise it's going to go very, very more faster. You see what I'm saying? This is not even faster for me. So equal to, when you integrate, what question was there? When you integrate that one, cot means when you integrate cot 3q 3x dx, you get, okay, negative 1 over 6 cot 1 3x square. You can take square here, and you said minus 1 over 3, and then ln of absolute sine 3x, and then you plus constant. Why plus constant? Because there's no limit. So we're done with that question. Now we go for the next one. Let's go to the next one. So make sure if you're recording, right? Because I don't want to do and then maybe it's not recording. Yes, it does record. Okay, cool. Let's go. Okay, cool. Now let's go. So the next question here, whichever you want me to start with. Okay, which one? Okay, let's start with the this was the second one. So they gave us integral. Okay, so this is by parts. So 1, 2, and then ln of x dx. So one more do left. So since this is by parts integral, you know, you can just go to my video, you see how to integrate by parts, whatever. So if it's integral by parts, you know, by parts you integrate like this. Integral u dv equal to uv minus integral of d du. So what is u? U is everything here for this case because ln of x. So you don't want to integrate ln of x. So I'm going to say for that case now, excuse me, I'll say let u equal to ln of x or square, okay? Because you have to compare with this. This is u, and dv equal to dx, and dv equal to dx. So when you differentiate this, it's going to be du. Okay, so how you differentiate this is product rule. Product rule means the first one must be constant and then differentiate the second one. So ln of x squared means like ln of x times ln of x. So this is a product rule. Put this constant and then differentiate this. When you differentiate ln of x, you get 1 over x. Or in other words, write 1 over x before ln x, the good way of writing. So you say 1 over x, and there's a ln of x, that's the best way. Plus, now the other one is going to be constant, so they're the same thing. So it's going to give us the same thing, 1 over x. When you put them together, this is the same, say, but here you differentiate what? X, so it's dx. So du equal to, when you put this together, it's like 2 ln of x over x. Oh, but we got your dx. So we got du already, okay? Now we want to go and integrate this. Okay, so let's integrate this one. So we integrate this, dv equal to dx integrate. So it's going to be v equal to x. So we got our du, v, everything. So we can substitute in the equation. So we substitute in the equation here. This is going to be integral. Exactly what we're looking for. Equal. Everything what we're looking for here. Integral 1, 2 ln of x square equal to uv. What is our u? Our u equal to ln of x square. Ln of x or square minus times v, because uv. What is up? V equal to x. So I like to write x before ln. So x and then ln square minus integral. Now we can make it be what? V. What is up? V equal to x. Okay, and then v and then du. What is du? Du equal to 2 over. So 2 and then ln of x over x, and this must be dx. X and x cancel. Let's take it cancel. So we say. This and we say, okay, so now we have, remember you have to have your limit, but for now, let's just wait. Or you can write your limit here, 1 to 2, here also 1 to 2. So now, this is what I have for now. So I'm saying, I hope you can see. So now what I'm going to do, I'll take this one deal with, because x and x cancel, so I'm only left with the 2 ln of x. Take 2 behind. So here, I'm left with x, ln of x, okay, our limit 1 to 2, and then minus integral 1 to 2. Okay, so 2 goes behind. Okay, 2 goes behind, so I'm left with the ln of x dx. So this is by parts also. So I'm saying integral ln of x is by parts. So what I'm going to do, let me make a space and come and solve here. I got like 50 questions here. So I'm saying you're going to stay with me. Okay, cool. So let's just take this one and integrate separately. So integral 1 to 2 ln of x dx. Okay, so what we're going to do, integral of u dv equal to uv minus integral v du. So u equal to ln of x. So u equal to ln of x, let u equal to ln of x, and dv equal to dx for this case, because it's going to be this one. This is equal to u, because we're trying to compare with this, and dv equal to dx. Okay, integrate. So this is going to be d, u equal to, and then when you differentiate this, it's going to be 1 over x, okay? And then dx. Okay, now you integrate v equal to x here. So let's go substitute straight away and get it done. Okay, excuse me. So now we're going to say integral ln of x 1, 2 equal to u times v. What is it? U equal to ln of x times x. So x, because u times v. X ln of x minus integral. Okay, now we go. So now we go to get what? V. What is it? V equal to x. Okay, and then du. What is it? Du is equal to 1 over x d. X and x cancel. So this is going to say, when you integrate dx equal to x, and here it's going to be x ln of x. Remember, you still have your limit equal to 1 to 2. So this half now, we know, means integral of ln of x starts from 1 to 2. We know 1 to 2, don't forget. So first, I'll take it here, back. So this is say x ln of x, our limit to 1 to 2 minus 2. Okay, x ln of x minus x. So it's going to be x ln of x minus x. But this also limit to 1 to 2 also. You know what I'm saying? So I can say, before limit, this is what we have. But if you substitute the limit, okay, means upper limit minus lower limit. Okay, what is the upper limit? 2. Means everything must be 2. It's going to be 2 ln of 2 absolute, and then minus 2, and then it's going to be 2 ln of 2 minus 2. Okay, this upper limit minus lower limit means take this 1, substituting all the value of x. It's going to be 1 ln of 1. Ln of 1 is 0, so ln of 1 equal to 0 is going to be 0, 0, 0, 0. Okay, so this is going to be 0 everything, because 1 times 0 equal to 0. So we know this is going to be 0 minus, okay. This is going to be 0, it's going to be 2 times 0 minus 1. Okay, plug in the calculator, this is going to give you 0.188. So we're done with that question. So now we go to the question number 3. Question number 3. Okay, let's go to question number 3, guys. Quick. Okay, let's go question number 3. We got 50 questions, okay? We got 50 questions. My whiteboard is getting dirty. Let me just wipe using some because I don't have a good whiteboard, so I'm just using handy to clean up my whiteboard, so when I continue to solve, you can see. So, you know, we stop the time a little bit so I can wipe my whiteboard well, because this is going to take a little time, okay? Just a little second. Please, guys, sorry. Pause the time a little bit because I use handy here to clean. Okay, cool. Let's go. Okay. Just a pause time for me, guys, please. Just pause the time a little bit because I use handy. You can see here, you know, I don't have a good whiteboard, so if I don't do that, then it's going to be very dirty. So pause the time for a second, please, and then we go back. Okay, so see, now it's better. It's kind of clean a little, okay? Okay, cool. Let's go. Ready to run. Let me take this one, so I'm going to dry it with this. So just use the water. Okay. Okay. My African mask just falling. Okay. Okay, just a second, guys. Okay. Thank you so much for your patience. Okay, cool. So I think I'm ready to go again. Here we go. So now the question is done. Now we go to question number 30. So this one here, first I'm going to do, okay, look. These are, I know for facts this is going to be completing the square, because now look. Sometimes it could be substitution and completing the square, but it cannot be substitution because you don't have something on top. So when you give this type of question, what you do is, look, if somebody give you stuff like this, let's say it was -4, let's say, I forgot something here, that's not right. Let me take my paper. That's not right, it don't make sense, okay? Okay, let me see, something wrong here. Let me see, so plus 4x. Yeah, that's x squared. I knew, okay. So how you do substitution? For substitution, look, if this was substitution, you know how it would be? Like, substitution means when you differentiate this, you must get something on top. And if you look, this is going to be 2x. When you differentiate, this going to be -4. We don't have anything on top, so we cannot do by substitution. So there's a chance this will be completing the square, and then completing the square. After completing the square means we can get trigonometric, and then we can start from there, okay? Now let's go. So what I'm going to do, I'll just complete the square this one. So let me take x squared, and then -4x plus 20. So if you complete the square, it's going to be x squared, and then -4x. And let me separate this, going to be 20 now. I'm going to say plus, take this divided by 2, and then square is going to be 4, and then same thing, if I plus it, minus, okay. This is going to be x minus 2, okay, because this one you factorize, and this is going to be what? Plus 16. And this is going to be 4 square plus x minus 2 square, okay. So instead of this could be, you can just go to completing the square. If you don't know how to complete the square, you can learn, okay. X minus 2, and then square plus 4 square plus 4 square. Can you see? So this is tan trigonometry by tan substitution. How are we going to do that? Look, if somebody give you integral, so these are rules, guys. Listen, if you never know or you never do trigonometry, there's a rules in integration by integration. So you need to learn and memorize those rules. When you come here, it's easy. But now I'm going to explain to you how that comes about and how you can memorize. If somebody give you, let's say this is d of x, and then give you, let's say a square. A means can be anything, and then plus, let's say f of x. So you see, it kind of look like a is like 4 square. A square means 4 square, and the function is this one square. So I had to change the whatever I have into this format, so I can just do a 3D tan substitution in integration. So now this is tan. Whenever you have a plus here, you have a square plus fx. This is tan. So how you write it is going to be 1 over. So first and foremost, make sure you take 1 over. You differentiate whatever you have here. You must differentiate this, and then also you say 1 over a. Or of this a, and then you say add tan, and then you can take f of x here, this f of x here, and then you over a again plus constant if there is no limit. So this is tan integration substitution. So say, okay, so for that case, this is going to be the same again here. So say, oh, equal. So when you integrate this, it's going to give me, okay, 1 over. So we have to differentiate the function. What is the function? The function is x minus 2. This function must be differentiated. So what is the function of x minus 2? When you differentiate x minus 2 means you get only 1. So just a 1. And then 1 over a. What is the a? Our a equals 4. And this is tan or add tan. Okay, let me write here because the space is very small. So see, 1 over, okay, differentiate. When you differentiate the function, what is the function? This one, x minus 1, x minus 2. When you differentiate x minus 2, you get 1. And they say 1 over a. What is the a? A equals to 4. So So I'm saying, okay, now we say equal to arctan f of x. F of x is x minus 2. And then we over a. What is a? A equal to 4. And then we plus constant because we don't have a limit. The question is done. Okay? F of x is something here with the x. So first you have to rearrange all these functions so it can be in a format of what of? Tricky substitution. But sometimes it can come as a sign or whatever cause. So you need to memorize those rules of substitution. Okay. Now this one is done. Let's go to the next question. Never mind. I'm not going to pick up anything. We just keep moving. Okay. So the next question also is going to be the almost similar strategy. No, it's not. So it's not. Okay, let's go, guys. Okay, cool. Let's go. So this one here, okay, let me show you this trick is very, very important. If you have integral, okay, you have integral, and then here, let's say you got, so this should memorize. It's in a standard form of integral. They give you in a table most of the time, but I want to show you how to use it because they can give you in a table, but you don't know how to use. So if somebody give you this and they say here a square minus f of x square, and then here f prime. Okay, so what that means, look, if I have a means can be a number, let's say 9, 49, a square like 49, or any number, let's say 25, or whatever square. So means if you differentiate this, you get this one here, prime. If you have anything in this format, so this let me say, okay, a square over 2. Most of the time I memorize this stuff. And then say arcsine f of x over a plus f of x over a, and then you square root a square minus f of x square dx. No, it's not dx. It means you have to differentiate, you integrate. Plus constant. If there is no limit, it means you plus constant. So now what I want to do, if I look careful, this is like, can you see the format? It can look like this, but it's not the same. So I'm going to have to play around so I can make it look like that. So what I'm going to do, first and foremost, what I'm going to do, completing the square. So you need to know how to complete the square because it plays a major role in this type of question. So I'm going to take, okay, so first and foremost, I need to have a square. This is not a square, means I have to get square of a number. So I can make it 49. So they didn't give me 49, so how I'm going to do? I was okay, so I'm going to do it in a way that is not going to change any meaning. So 49 minus 1, still 49 minus 1 means it's still 48. Okay, and then here I'm going to start to this one. So I say, okay, minus x squared, and then plus 2x, and then, okay, dx. And then what I'm going to do, okay, so this, look, I'm going to have to pull this together. So I'll say 49 minus, okay, let me start with the x squared. So if I start the x squared, if you take negative out, it's going to be x squared. Now let me go for this, so this is going to be negative 2x, and this is negative, right? It's going to become positive 1. If you put it in, look, it's going to be the same thing, okay? Okay, so now if you factorize this, it's going to be x minus 1 squared. If you expand it, it's going to be this, okay? 49 minus, okay? Integral. So can you see? This is in this form. And when you differentiate this, you get 1, which is a prime. When you differentiate this, x minus 1, you get 1, which is like when you differentiate this, you get this. Yes, so means this rule can be applicable. So this is equal to a. What is a? A means this number. A squared. A squared. A squared. Instead of 49, I can say 7 squared. A 7 squared over 2 arc sine f of x. What's my fx? X minus 1. So it's going to be x minus 1 over a. What's my a? Equal to 7, and then plus f of x. Fx x minus 1, and then over a equal to 7, and then square root a square minus fx. A square minus fx means this. But this is the same as this, is the same as this, is the same as given one. So I can take this one right there, or I can write this, and then after I write that given. So I can say, okay, so let me write this, because it's a square equal to 72. But this came from that. Okay, 7 square, let me start first, step by step, minus x minus 1, and there we go, you got square. Okay, so plus constant. So this, let me say, I'll write exactly everything, and then here, plus exactly everything, but this equal to, for 8, plus 2, x minus x square, minus, plus constant, because there's no limit. Write everything exactly, and you're done. So this question is done. I got my paper here, and then I can continue the question, okay? Let's continue the question. Let's wipe the whiteboard quick. So this question is done already. So we want to move quick. I want to make sure I finish all this question, guys. Okay, finish all this question, man. Man, see my whiteboard is had a problem. It kind of stacks some dirty. That's why I use handy most of the time. Okay, cool. There we go. Let me use handy a little bit quick. Okay, sorry guys. And after handy, I put some water now and they wipe it now. Now it's gonna get clean, you see? Put some water now quick. I got a bucket of water here. Can you see bucket of water? Okay, cool. Here we go. Okay, now we wipe with the water. We got to wipe with the water and then I'm gonna dry it and there we go. So just pause the time for me, guys. Just a second, there we go. Because, you know, I don't have an alternative with this. Otherwise, it's going to be dirty that you won't be able to see. Here we go. This is raw and cut. I'm not going to cut anything to keep moving. Here we go. Here we go. I'm not going to drink water. I'm not going to drink anything. Here we go. Okay. Cool. Let me get paper. Let me go my question. So we got a lot of question here. Okay, cool. Ready to go. Okay. So we got this question here. Okay, let's see. For x, this is more easy. X cubed. Oh. X cubed minus 3. Square root of x plus 12 over square root of x. Square root of x dx. So this is the power rule of integration. I'm going to separate each one. So integral of this divided by this is going to be 4. I can take 4 out. 4 out, so I'm left with x cubed. And then this one, this with this, this with this, and that's with that. You know what I'm saying? So it's going to be this one. And but this is like x a half dx. Minus minus. This is 3, take 3 out. Integral, square root of x dx. This and this cancel. Okay, plus 12 is just 12. So integral of d dx. 12 over square root of x. So what we're going to do now, it's going to be 4 now. Same base, so it's going to be x and x. It's going to be x and then 3 minus a half is going to be 2.5, which is 5 over 2 dx. And then minus 3. This in this cancel is like integral of dx. Integral of dx equal to integral of dx equal to x. So it's going to give us x minus plus 12, so you can reciprocate this going to be integral x negative by half because it's going to go to the top. So this is going to be 4. This is a power rule. Means if you have a power rule, means it's going to be x. Take this add by 1. So 5 over 2 plus 1 is going to be 7 over 2. Same thing you write here, right at the bottom. Okay, minus 3x. Okay, this is going to be 3x. Okay, plus 12, and then it's going to be x negative by half plus 1. It's going to be positive a half, and then positive a half plus constant because you don't have a limit. So now this can go to the top. It's going to be 80 over 7x, 7 over 2. Or if you don't want to do that, you can just say 7 over 2, right? Or you can say 7 over 2. Okay, write 7 over 2 is fine. So I'm saying, or if you don't write 7 over 2, you can write by 7 and then you can write root. So whatever you would prefer. Okay, let's say 7 and then root. So x plus 7 and then root. And then for that case, now we go minus 3x plus this is going to go to the top 24x square root. Okay, plus constant. We're done. We go to the next question. Okay, next question. This is the easy one. Let's go to the next question. Okay, so the next question here, I'm trying to check here. Okay, so we got integral ax squared, x squared, and then we got plus bx plus c, and we got a root of, okay, oh, the space is not enough there, I started too far. Let me start from number right. So we got integral, ax, okay, square plus bx, plus c, and then we got root, okay, 2ax cubed, and then plus, okay, 3bx squared, and there we go, plus c, 6, cx plus d, all these are root d, dx. So me, what I'm going to do, I'll let this equal to u, or in the left, because I know if I'm going to differentiate, it's going to give me this. So let u, okay, whatever letter, okay, 2a x cubed plus 3b x squared plus 6cx plus d. If I differentiate this, it's going to be du equal to, okay, 3 come here, it's going to be 6 ax minus 1 is going to be 2, and then plus 2 times 3 equal to 6, and then bx, because 2 minus 1 equal to 2 minus 1 equal to 1, and then plus this is going to be cx, okay, c, okay, all this is going to be dx. So I'm saying, so you kind of count there, okay, so I'll take 6 out. If I take 6 out, it's going to be 6 out divided by 6 is going to be du. Okay, let me just so slowly. So it's going to be a x squared plus bx plus c dx divided by 6. So this and this can just cancel. So all this stuff you got du over 6 means if I had to replace this with it in the dx together, all of them equal du over 6. So it's going to be integral. Instead of write this and this together, I'm going to write them and say du over 6. So this 6 can come to the back because it's like over 6. So this 6 is going to come to the back, and then we have a square root. You have a square root. But this we know equal to u. It's going to be u, and this equal to 1 over 6 u. It is like a half. So if I don't write this, it's like a half. So it means that's a power rule of integration. So we add 1. Half plus 1 is going to be 3 over 2, and this is going to be 3 over 2. This and this is going to be 3. 3 and 3 equal to 9. So this and this is going to be 3 equal to 1 over 9 u power 3 what? Cube root. If you don't want to write, you can write like a plus c. But I don't know the value of u. So what I'm saying, what is the value of u? The value of u we know equal to that one. So this may say 1 over 9, and then we know the value of u. Plug in that exactly to 2ax cubed plus 3bx squared plus 6x plus d. Okay, and the bracket cube and the plus c. So we're done with that question. Now we go to the next one. Okay. It's getting dark now. It's getting dead. I should use handy hand again, quick. Now let me do one more round and then I'll do the handy hand thing. Maybe I can just use it because it's going to be dirty now. And then you want me to see clear, so put my handy hand here quick. Okay. Okay, cool. There we go, guys. Please, man, if I put the handy hand, you can put a pause in time, please. This stuff is shaking a lot. Let me put, okay, I'll figure out why is that. Okay, cool. We got it. I don't want to shake over there like that. I'll put my water. Just put it, pause in some minutes, guys. Okay, put in the water quick. Okay, here we go. I'm ready to go. Ready to go. Ready to go, man. Ready to go with these. Okay, cool. Okay, cool. Okay, wipe now, so I'm gonna dry it. So now you dry it. You can pause my time, just a second, guys. Pause the time, and there we go. Okay, so this is very easy. Now, let's go to the next. The next one is, okay, cool. We got it. Okay, cool. So we got this integral 0 power 4 sine cube x, and then we got cos cube also x dx. So what I'm going to do with person, I'm going to break this into square and 1. So this one is say integral 0 power 4. This is our limit, and then it's going to be sine cube x. This is going to be cos square x, and this is going to be cos x. This is going to give us cos cube. Cos square plus cos equal to times cos cube dx. So this one I can replace by saying from trig identity equal to 1 minus sine square. So integral 0 to power 4 sine cube x, and this is going to be 1 minus sine square x and then cos of x dx. You know what I'm saying? So what I'm going to do, I'm going to multiply that out for each one. So integral 0 power over 4. Now you take these multiplied by this multiplied by this. It's going to be sine cube x and then cos of x, because these multiply and then you also multiply by that. Or if you think you're confused, you can just write this with it. Okay, you can write like this if you're confused. Start this one first and then come this. I think you understand what I'm saying. You know what I'm saying? Or you can write like this. Say integral of 0 power 4 and let's say sine cube x cos x 1 minus sine square x dx. So when you multiply, it becomes easy. Sine cube cos x, and then you count this for the second one, and then dx minus integral 0 to pi over 4. And when you multiply for the second one, it's going to be sine power 5x cos x dx. So what I'm going to do now, I'm going to take this separately. You see what I'm saying? I'm going to let u equal to sine x. So du, when you differentiate, is going to be cos x dx. So cos x dx equal to du means this equal to du. So integral 0 power 4. Okay, so sine, instead of sine is a u, so it's going to be u cube. And this cos x dx equal to u minus. We're going to do the same thing here, but you know, this limit you can leave it for now because now everything is above u. So this is not right limit. So you can just leave it and then you can substitute later. Or if you want, you can just write, it doesn't matter. Okay, cool. Because these are limits of x, and now we have a u now. Okay, this is going to be u power 5, and then it's going to be du. Okay, this is a power rule. It's going to be 3 plus 1 equals 4 over 4 minus 6 plus 1 equals 6 over 5 plus 1 equals 6 over 6. We know them. Okay, so we're going to have to substitute. Now we know the value of u. What is our u? Our u equal to sine of x. So it's going to be sine x power 4, and then over 4 minus sine x power 6 over 6. Now you can write your limit because the limit is 4, the x 0 pi over power 4. So now you can substitute upper limit minus lower limit. Okay, so upper limit, this is same as, okay, let me show you pi over 4. So sine pi over 4 over 4 minus, okay, upper limit is going to be sine, okay, pi over 4 over 4 minus sine pi over 4 power 6 over 6. All these lower limit equals to 0 means it's going to be 0, 0, 0, 0, 0. So plug in the calculator this. If you plug in the calculator, you're going to get something. Okay? Get something. Man. Okay, you can just plug in the calculator. I don't have a calculator with me and I don't want to waste a lot of time. I know you can plug in the calculator. Okay, cool. Now let's continue to the next one. Let's continue to the next one. I'm trying to pull the calculator, but I don't see my calculator, okay? Go to the next one. Let's go to the next one here. Okay, cool. Let's go. Wipe. Just dry. Try. You can pause my time on the erase because I use handy. I don't have a good eraser here, so these things take a lot of my time. Erasing stuff, and I hate this stuff. Somebody should come and help me to erase. Okay, I'll appreciate that. Let's go for the next one. So the next one, integral x arc. There's an arc sinh x squared dx. When you say arc and inverse is the same thing. If somebody say arc, let's say arc tan x or function of x, and if somebody say tan inverse of f of x, the same thing. So the arc is like the inverse meaning. So you can write them both together. Either you write arc tan of fx, you can say tan inverse of f of x. Now we go. So this question here, they say, is essential, or I want to make sure here. Just a second, guys. I think it's sine. Oh my God, is it essential? Sure, I can't remember now. Just a second, guys. You can pause the time, alright? I want to make sure I copy the. This is sine x squared. There's no essential here. Sine x squared. Sine x squared. x squared. Okay, cool. Let's go. Let's rumble this. So this is easy. So this is integration by part. Whenever you have an x or function with a sine or cos, integration by part. So I'm going to say this is equal to integral. This is finished. U dv equal to uv integral v du. Okay, so what is a u? Most of the time you have an x with a inverse. Let the inverse equal to u. The inverse equal to u. So u equal to sine inverse of x squared. Okay? So now differentiate du equal to, when you differentiate this, remember, look, if somebody gives, say, differentiate at sine, let's say, of a function. So this is what you do. You say this is semi-prime. You differentiate this function. Then you put square root and they say a square. What is it? A square minus this function here with no prime. So this is what you got. You know what I'm saying? So don't write 1 over a. No. What you do? Differentiate this. A square minus a. Okay, so I'm going to do the same thing. Differentiate whatever is in here. What is this? This is x. When you differentiate, you get 2x over square root a. What is that a? A is like a number which is in here below. So a equal to 1 square minus 1 is equal to 1 minus fx. Fx is x square. This x square. But what you have to do, you have to square, because it already has a square, and then you square, and then you say dx. So du equal to 1 minus x power 4. Okay, dx. So these are du. This is u, and then we get u. Now we go for dv. So this is u, so we need dv. dv equal to, so there's no dv equal to x. So it's okay. So dv equal to dx. I mean dv equal to x. dv equal to x, but with what? With x with dx, because this was u. So dv equal to this when there. X dx. So what we do, integrate. So v equal to x squared over 2. So we do substitute back in a given equation. So now it's going to be integral of u dv, which is that one given. So it's going to be integral of x arc sine x squared dx equal to uv. What is the u? Our u we got here now. Equal to this one, sine. Okay, times v equal to x squared over 2 minus is just a minus. Now we go. Integral v. What is the v? Our v equal to x squared over 2. X squared over 2. So this is going to be x squared over 2. Okay, and x squared over 2. And then after, I'm sorry guys, I was standing in front of it. My apology. X squared over 2. And then after x squared over 2, there's a du. What is a du? du equal to this one, 2. Okay. 1 minus x power 4. 1 minus x power 4. Okay. So what we're going to do, we take this alpha. So what we're going to do now, we say, okay, now let's continue. These two and these two cancel. So here we got x power 4 and that one right there. You know what I'm saying? Let me see. I think I forgot something here. You know what I'm saying? Because x squared. And then when you integrate, I feel like I'm going to say v. Okay, now this, I forgot x here. I knew. There's an x here. There's an x there. So this must be x here. So what I'm saying, I forgot my x here. Okay, so now let's continue. So this is going to be equal to x squared over 2 sine inverse of x squared, and then minus. Now this is this cancel. So this is going to be x cubed, and there we go. 1 minus x power 4. So this is a normal substitution. So we here, but I can deal with this first, and that will come in substitute. Let's call this one first equation. So now, okay, cool. Let's just, what is it? I don't need this anymore. Space. Okay, so I'm here, right? So now I'm going to let, oh, it's very wet. So let u or whatever letter, or m, let's call m now, or t, because we've been letting a lot of u here. T equal to 1 minus x power 4. If you differentiate, it's going to be dt equal to, it's going to be negative 4, because this 4 come back, x, 4 come back, and then x, 4 minus 1 equal to 3 dx. So this is, look, this is like x3 dx. x3 dx. So x3 dx equal to dt over negative 4 because you divide by negative 4 over negative 4. Isn't that cancel? Okay. So x3 dx equal to dt over negative 4. So I can replace this by dt, and then 1 negative 4 is going to go back, like saying negative 1 over 4 dt equal to x cubed dt. You know what I'm saying? So that means x dt equal to, okay. So I'm going to place here. Let me deal with this like I said, okay. Only this, and they'll come and substitute back. So it's going to be, okay, integral, okay, x dt, x cubed dx, x cubed dx equal to negative, okay, so negative 1 over 4 is going to go back, and then we got dt here, dt. But then, this look, equal to dt, negative 1 over 4 went back, dt is here. And then this is going to be, okay, this one we know 1 minus x4, 1 minus x4, 1 minus x4 will let equal to t, so it's going to be equal to t. So this is equal to negative 1 over 4, let me do this, negative 1 over 4, and then I can take this to the top, so integral t negative 1, half d dt. Okay, now this is going to be negative 1 over 4, now this is going to be t, okay, negative 1 plus a half equal to a half, so this let me say negative 1 over 4, okay, and then this line, square, a half on top, and also half on the bottom, because not on one side. When you plus the top and the bottom, this and this cancels. When you cancel, it's going to give us 2 here. So it's negative 1 over 2. Okay. T a half equal to square root of t. But what's the value of t? The value of t we know. Value of t was the value of t. 1 minus x power 4. 1 minus x power 4. So we know this value is going to come in here because we know the value. So now we say, okay. So finally, when you integrate all this stuff equal to x over 2. Sine inverse, so we can say arc sine or sine inverse of x squared, and then minus this stuff is this or this guy. So negative 1 over 2, negative 1 over 2, negative 1 over 2. Oh, wait a minute. There's a negative 1 over 2 and there's a negative, so it's going to make it all positive. Because if we got negative, okay, negative, and this negative is going to be positive. I hope I go correct. You can correct me for maybe I made a silly mistake here. It's going to be plus a half. It's going to be 1 minus x power 4, and then plus constant. So we done with that question. Let's go to the next question. Let's go to the next question, man. It's very dirty now, so I have to use this handy quick because it gets very dirty. No water, no nothing. I'm going to drink water until I finish all this question today. See, it's very dirty. That's why I have to use a handy, okay? Pour my water. Please, pause my time, guys. Oh, the water is very dirty as hell. See, doesn't even clean correctly. Okay, so take my arm over my pocket. We're almost finished. Let's go, guys. Yeah, this is way better. Okay, cool. Let's go. Man, this is Africa. Sometimes the power just go off, you know. So please just be patient with me. It's come from Africa, man. Okay, cool. Let's go to the next question. Next question to see, I think this one done. Okay, we got the next question here. Let's go. This one, they say integral. Okay, since 1 plus cos. This is very easy because this is just a substitution. If I take this, let's take, okay, so let u equal to 1 plus cos x. Differentiate du equal to, when you differentiate 1 you get 0, when you differentiate cos you get sinh dx. So this equal to du. So let's say integral du, and then it's going to be 1 over, this is equal to u, because u equal to that one, u. So this is equal to, whenever you differentiate integral 1 over f of x dx, this same say ln of function. if you have a fix at the bottom. So this, let me say, so this is same in that one. So it's going to be ln absolute of u plus constant, because we don't have a limit, so you can just say constant. So this is equal to ln, okay, u, what is a u? U equal to 1 plus cos x plus constant. So we're done with this question, we go to the next one. Let's move, baby. Let's go. Okay. Next question. Okay, these one are done. Just see. Okay, so now we come here. Okay. Okay, we got a question here. Okay, integral. So we got e 5x, and then we got sin 3x dx. So what we're gonna do, this is easy. Me personal, essential course, yeah, essential. So this one we know. Okay, I'm gonna write this in terms of e. If somebody gave you, so this is integral e5x, but a sinh, the meaning of sinh of a whatever function is, let me say a half bracket. Write this on here. You say power minus. For sine you say minus. For cos you say plus. So it's going to be e and then negative. You must be negative here. You memorize this, okay? Equal to, no, divided by 2, so 2 is here. So then we got dx. It's like if somebody gave you, let's say, cos, let me write for you so you can memorize. Let's say, cos, let's say 2x. So this is, say 1 over 2, but if it's cos, it must be plus here. Sine now is minus, so say e, and then you take this value here, you write it on top. It's plus because of cos. It's not cos, it's cos, okay? It's cos, yeah, cos, my fault, cos, okay? Plus e, and then write minus 2, and then sometimes people write under 2, or you can write outside, whatever you prefer. But for sine, it's going to be minus, just like I wrote there. Now we go. So we know it's time here because it's not part of the anything, it's not part of the question. Let's go to our business. Okay, so what we're going to do now? So this is normal exponential rule. So I'll take a half outside, so half is going to go outside in the rule. Base are the same, so I'm going to multiply e. It's going to be e. 5x plus 3x is going to be 80x minus e. Okay, 5x, base are the same. 5x minus 3x is going to be 2x dx. So now we know integration of exponential. Integral, let's say exponential f of x. So that's what you say. Differentiate whatever you have there, and then get f prime, this f prime, and then write exactly what you have here. So I'm saying just differentiate what is there and then write exactly. So we're going to do the same thing here. I can separate face. A half integral of e 8x dx with the face on the integral of e 2x dx. So now I'm going to apply the rule here. It's going to be a half and this is going to be e. Now differentiate whatever here. When you differentiate 8x you get 8. So this is going to be over 8 and then write exactly. Minus, so it's going to be 1 over 2 because differentiate 2x you get 2 and then e 2x and then we plus constant because you don't have a limit. So this let me say 1 over 16 because you multiply that out and then e 8x minus and then you multiply that out, it's going to be 1 over 4e 2x plus constant. We're done with this question, go to the next one. Let's go. We're done. Okay. Okay, so now we go to the next question. The next question, okay, I see, okay, integral. Okay, we got integral here, integral. Okay, dx. They got 2 minus 4x minus x squared, 4x minus x squared. So this, it kind of look like, because it look like a tan inverse or sine inverse, but it cannot be tan because it has a root. So I'm going to do completing the square quick. Can I do substitution? No, because you don't have something on top that you can differentiate this and get whatever numbers on top. So what you can do, completing the square. So I can start with the x squared. and I have 4x and then plus 2, like this. Take negative out, I complete the square, right? And then plus 4x, because if I take negative out, it's going to be minus 2. I can separate that. So say minus 2, separate here. Because this should take, you take negative out, it's going to be plus, and this is going to be plus, and this is going to be minus. But I separate because I want to complete the square. X squared, and then plus 4x, and then I take this 4 divided by 2 and then square is going to give 4, negative 2. But since here plus here must minus, so it's not going to make any difference. So minus, oh, this pen is finished. Minus, and then here it's going to be x squared. No, let me factorize this. It's going to give me x plus 2, and then what you square. This and this is going to be negative 6. Okay, put it in. So this is going to be positive 6, and this is going to be minus. So instead of saying that equal to integral, and there's going to be dx. Okay, now excuse me, it's going to be 6 minus 6 minus, man, this pen is not good at all. It's finishing, man. Okay, minus x, okay, dx. So this is sine trigonometry. How did I know? Let me show you something. If somebody give you integral dx, and then here they give you square root of, let's say, a squared minus, it must be like this, minus, and here you get f of x. This is sine trigonometric by sine substitution. How you gonna know it? So now this means you say 1 over, but for this case don't say over 1. For tan you say over a, excuse me, I mean over a. For tan you can say over a, but for sine don't do that. So this is going to be f of, differentiate there, f of x, and then say x sine, or you can say sine inverse, and then write your f of x here, and then over your a plus constant, because there's no limit. So for that case, look, this a is not in square. But look, if somebody give you 7, and if you take this 7 and then you square it and then you square, it still doesn't make any difference. It's the same thing. So if somebody say 2, 3, because if it's 9, then you can say 3 square. But if it's 3, you can, look, if somebody says 7, or let's say, 5. 5 is not in square root. But if it was 25, so 25 means 5 square. But if it's just a 5, so you will have to write like in the form of a square. So this time I say, I'm going to square root and then I square. It's still 5, because when you square root and then square, it's in this concept. But the reason why I write like this, so I can have like a square. So I'm going to say, I hope you understand. Here we go. So now I'm going to say, so for that case, instead of say 6 now, this is the same say integral, okay, dx, I can say 6 square root and then I square, and then minus x minus 2 square, but we still have our handout. So now that's a sign now. So this is the same as this one, because my a equal to square root of a, look, equal to a, and this equal to x minus 2. So what I'm going to do, I'm going to say, okay, so now 1 over f, 1 over, differentiate f of x. These are f of x. When you differentiate x minus 2, you get 1. Because when you differentiate x equal to 1. Now come the arc sine. My pen is finished, guys. Man, I want to continue, my pen is finished. Come on, man. I want to start these things. Okay, cool, let's go. Okay, so arc. Yeah, I got this one. Arc what? Arc sine. Arc sine, f of x. What is f of x? F of x is x minus 2. X minus 2 over a. What is a? A is the square root of 6. This one. This is square root of 6, and then we bracket the plus constant. Why plus constant? Because we don't have what? We don't have a limit. 1 over 1 equal to 1, so I don't have to write this. It's just a 1. Just like arc sine, x minus 2, square root of 6, and then plus constant. Okay, we're done. Let's go to the next one. So the next one, say, okay, cool, we got it. Okay, I got it. Let's go. Man. Okay, cool. Can I use the handy? Is it clear? It's not too clear, but it's fine. Let me do one round and then I can do the handy stuff and clean it with the water and that cleaner. substance, I mean cleaner chemical, so it can be more clear. I hope it's little somehow. Okay, cool. I think we can do a whack one more. No drinking water, no nothing. Okay, let's go to the next one. The next one say okay, I see. Okay, so we got integral here. Integral x 4 plus x squared. Yeah, this is square root here. Dx. This is easy because I'm going to do substitution, because I know if I differentiate this, it's going to give me the one on top. So you see this, you don't have to do this completing the square, because if you differentiate this, x squared is going to give you x. So no need for you to do completing square. So I'll say let's say v. Any letter, most of the time they say u or whatever, equal to this one. So when you differentiate, this is going to give you dv. When you differentiate, this is going to be 0, 0 is going to be 2x dx. So look, x dx, so divided by 2, divided by 2. So divided by 2 and then divided by 2, this and this cancel. So okay, so x dx equal to dv over 2. So I'm going to say integral x dx equal to dv over 2. So it's like 1 over 2 dv equal to x dx. So I can take 1 over 2 outside, so I'm left with the dv, and this is 1 over square root. This equal to v. So now this equal to 1 over 2, and I can reciprocate. Integral v equal to the top is going to be negative half dv. You see what I'm saying? And then this equal to 1 over 2, and then when the other half is going to be v a half, but also at the bottom must be half. This and this cancel, plus constant, so equal to v. This is going to be 1, so it's v square root plus constant. Okay, v we know. What about v? Equal to 4 plus x squared. Okay, we got square root plus constant is done. Let's go to the next question. Okay, let's go to the next question, guys. Okay, I'm gonna increase my speed now. Okay. Okay, cool. Here we go. So we go to the next one. Integral. Okay, dx, okay, dx, and they got 4 plus x squared, 4 plus 3x squared. Okay, cool. So what we're going to do, okay, so this is tan, but I'll show you how. Okay, so this is the integral dx, and this is like 2 squared plus 3. See the same thing I told you before. 3x squared, and this is going to be x squared. So this is the same as 3x squared because it didn't make a difference. So this, let me say integral dx squared, and then say plus square root of 3x, both of them are squared. Okay, it didn't make a difference because you square inside, it's going to give you 3, and then this is going to be x squared. Now look, this is Tang substitution. How do you know? If you have this Tang, let's say this is dx, and they give you a squared plus fx squared. So square. See, same with this one. A 2 fx equal to this one fx square. So this time is a 1 over a. Don't forget that. So for tan is different this time. You must say over a, and then here must be, you must differentiate this function, and then say at tan, or you can say at tan and tan inverse the same thing, and then write your fx here, and then over a plus constant, or plus constant because there's no limit. So for this case, you're going to say integral of this one equal to 1 over a. What is a? Equal to, okay, differentiate this. When you differentiate, it's going to be left with only square root of 3 because the x is going to go. And this is tan inverse, so you can say a tan or tan inverse, whatever you prefer. Okay, fx is this one over a. What is a? Equal to plus constant. We're done. Now we go for the next question. Okay, we go to the next question now. Okay, go to the next question. Okay, let's go. So the next question here, let's see, the next question, okay, this one's done, okay. The next question is integral integral, and then dx. Okay, and then 9 plus 4x squared. 4x squared. Okay, this also kind of look like a Tang. Okay, I think so. Kind of look like. Okay, so what I want to do now is say, okay, so this time say integral my dx. What is 9? 9 is like 3 squared plus 4x is like 2 and x, but are all them square. So this is Tang. I'm not going to write the formula again. We know how it goes because it's Tang. So 1 over a. What is my a? My a equal to 3. This. And they'll say, okay, tan inverse or tan, no, differentiate phase. You have to differentiate this, which is going to give us 2, and then tan inverse. Or arctan, whatever you want. And then write your function here, and then over your a, our a equal to 3. Write your function over your a, and then plus constant. So we're done already. We go to the next question. The next question now, let's go to the interesting stuff. Okay, cool, let's go. Interesting stuff. Oh man, there's another page here, man. That's why there's another question. There's more questions. Sorry guys. That's where I wrote the question. Man, where is it now? Yeah, I got it. Okay. Okay, cool. So we got here integral. And then x 4 plus x power 4. Okay, cool. There we go. So now, pen is finished, man. Okay, so what I want to do first, I will break this. I'll say this is equal to integral. This is equal to integral. We got x, and then it's going to be 2 squared plus this is going to be x squared power square. So it's like x power 4. So what I want to do, why did I do that? Because I see this is x and this is x power 4. So there's no way they can relate to each other. That's why I say x squared in square. In a normal, let x squared equal to the certain value, and they'll differentiate. So let's say whichever letter. Let's say u equal to x squared, because I will differentiate to get that one. Du equal to 2x dx. Okay. So x dx we know. X dx we know. Equal to divided by 2 divided by 2. So this is this cancel. So x dx equal to du over 2. Or you can say 1 over 2 du. Okay, so we can replace there. So this is going to become, okay, 1 over 2 is going to go outside here. Okay, du is going to be left with du. So here we're going to be left with 1 over 2 square plus, instead of x square equal to u, so it's going to be u square. So you see now we have a Tang formula of Tang substitution, but now in terms of u. So we know how we're going to do. So this is going to become, so that's going to become 1 over 2 is just still there. Okay, 1 over our a. What is a? A equals 2. And then what you do, differentiate whatever is in here. When you differentiate this, u is going to give you 1. You only differentiate without square. And they say arctan of your function equal to u over this number, which is 2 plus constant. But we know the value of u. The value of u we know equal to x squared. So replace now, this is going to be a half 1 over 2 arc tan, what is a u? X squared. C. And we're done. Multiply by. Or you can multiply that out. And that's going to give us, well, this is going to be 1 over 4 arc tan or tan inverse x over 2 plus c. We're done. We go to the next quote. Next question. Let's go to the next question, guys. Let's go. Next question. Ah man, let me do the handy quick. It's getting very dirty today. Sort of black guy, can you see? Just pause my time, please. Pause my time, guys. Pause my time, please. No break, no relax. Okay. I'm not giving you like, those integration of like baby stuff, you know what I'm saying? Give you something which is interesting, which worth your time, Okay. Okay, cool. Okay, we ready. Let's go, guys. Okay, you can set up a time. Here we go. Let's go. Okay, next question. This question here to give you integral dx. They give 7 minus 36x squared minus 36x squared. We got q. This look like a sine inverse, but now I'm gonna have to play around, predict what's gonna happen there, because now you know what is happening, man. You know what I'm saying? Okay, so this, let me say integral dx, and now 7 squared is square root of 7, and that's what? Square minus 6x square. Can you see that? See what I'm saying? So this is sine because you have a square minus fx square. So this, let me say 1, and you know when you have a sine is like 1 over f prime. Don't write your a for sine, okay? And this is sine inverse, so you can say arc sine and the fx over a plus constant if there's no limit. You know what I'm saying? So you do the same thing. So this happens if you have a square minus fx square. So we get this. So for this case, the same thing. A square minus fx. Okay, now 1 over differentiate fx because it must be f prime. When you differentiate x, you get 6. I'm sweating, man. Here we go. When you differentiate x, you get 6. Sine inverse of fx. What is fx? Fx is 6x over a. What is a? A square root of 7 plus constant. We done. Let's go to the next question, guys. Okay, cool. The next one, they say integral. No, this is a baby question. Integral, I think for the freshman, sine of x. Let's say 3x square. Let me do this. Integral sine 3x squared dx. So this is easy. First and foremost, I'll differentiate whatever I have here. When you differentiate that, it's going to give us 1 over. You must write 1 over. For integration, you must say 1 over. And then differentiate is going to give you 6x right here. Your answer after you differentiate. And then when you differentiate sine, you get negative cos of a function 3x squared, and then plus constant because you don't have a limit. So in other words, if somebody give you, so this is a final answer. If somebody give you this, let me write for you, sine g of x dx. So you say 1 over, differentiate this, and then right here, and they say cos, because when you integrate sine, you get negative cos, and then write your function. For this case, g of x plus constant because there's no limit. Now let's go. Okay, we have a arc sine. Okay, integrate arc sine. There we go. So let's say integral arc sine x dx. So what I'm going to do for the most case, whenever they give you this, you know what I'm saying? What I'm going to do, I'll differentiate this. Let this whenever you have it, differentiate arc sine, arc tan, arc cos. This is by parts. So integration by part, this is how we say integration by part. Say integral u dv equal to uv integral v du. So I'm going to do the same thing here. You know what I'm saying? So now, what is my u? My u is going to be everything here. So say that u equal to arc sine of a function. But for this case, it is x. So, okay, let me write here. If somebody give you arc sine of a function, and they say differentiate, this is say you find the prime of this, and then you over a square minus this function square. A square is like a number under this. See the number under this fx. For this case is 1. So for this case now it's going to be differentiate, this is going to be du, and this is going to be differentiated whatever you have there because it must be f prime. When you differentiate, this is going to give 1. A square is like a 1 square minus, like 1 square equal to 1 minus x square. See what I'm saying? Because this is going to be x, and this is going to be x square. And then we differentiate x here is dx. Okay, cool. We got that. Okay, now dv equal to dx. dv equal to dx. When you integrate v equal to x. So what we do now, substituting it, original form. This is this. So it's going to be integral arc sine x equal to uv. What is that u? Sine x dx, excuse me. uv, what is that u? Our u equal to arc sine x. And v equal to x. So I'll start with the x and then I'll go for arc sine x. And this is u and v. And then minus v. What is that v? Our v equal to x. du. Our du equal to 1 over 1 minus x square dx. So I want to deal with this and integrate as a substitution, because if I let this differentiate, I'm going to get the one on top. So let u equal to 1 minus x squared. Du equal to negative 2x dx. So x, because 1 times x is just x. So x dx equal to divided by negative 2, divided by negative 2, divided by negative 2. This in this cancel. So x dx equal to du over negative 2. So let me deal with this and that will come. Let me say this is first equation. So I'm going to say now integral, okay, x dx du over negative 2. So let me take 1 over 2 out, because it's like 1 over 2 out. So this is du and then 1 over, okay, square root square root. 1 minus x square equal to u. So this equal to negative a half. And then this is like u a half. Take to the top, u negative a half. Plus 1 is going to be u positive a half. It's going to be u positive a half is like square root of u. You know what I'm saying? So that's going to be square root of u. And then after that, we're going to say these equal to negative 1 over 2 square root. But what is that? U equal to 1 minus x squared. So 1 minus x squared. So this is going to come in here. So finally, I want to say is x. Let me use another color here. Maybe paint the red. It's going to make a lot of sense. So it's going to become x arc sine x minus. So all this stuff we know is negative a half per row. So negative and negative is going to be positive. Positive. So it's going to be a half and then square root of 1 minus x squared plus constant c. So we're done with that question. Let's go. Oh man, I'm done with this question that I brought up with the question I prepared. Let me see. There was a paper which found here. Yeah. Let me see if I got some more question or not. Oh yeah, I got a question here. So there's a question here. Yeah, there's a question. 3 more. Let's go. Okay, cool. Okay, we almost finished, guys. Let's go. Okay, cool. Now let's go. So the next one they say okay, integral. Okay, I have to take off my shoes. B, okay. Power 3x squared, power 3x squared dx. So this one we'll do, I'll differentiate this, because whenever you integrate, okay, let me write here. When you integrate let's say g of x, d of x, what you do, differentiate whatever you have there. So it'll be 1 over g prime, and then write exactly. Plus constant, because you don't have a limit. So for this case, differentiate that 1 over, it's going to be 6x, and then write exactly. Plus constant. Let's go to the next one. The next one say integral dx. Okay, 9 minus 25x squared. So this what we're going to do is a sign substitution. So this, let me say dx, and this is going to be 3 squared minus 5x squared Okay, so this is gonna be 1 over, differentiate this. When you differentiate, it's gonna give you 5, and there's gonna be arc sign, and then write your function, which is f of x, over the number which is in here. 3 plus constant. Okay, some more question? Yeah, this is the last one, the last question. Integral, okay, dx, okay, 7 minus 36x squared. So this time we say integral dx, and the 7 is like 7, and then we square. You know what I'm saying? Because this is going to be the same 7, didn't make any difference. The reason why I write like this, because of the formula of, okay, this is going to be 6x. Okay, the reason why I write like this, because this is sign substitution, because I know it has to be integral of f of x, excuse me, 1, okay, it must be like this, and then a squared minus f of x. So that's why I wrote like square root of 7 squared, because it's still 7, because when you square root 7, you square the same thing. So this is going to be 1 over, okay, differentiate 6x, is going to give you 6, and then arc sign 6x divided by square root of 7 plus constant. Guys, I'm switching, so we're done for the day. Listen, man, please let me know if the solving was sufficient, you learned anything from me, and thanks a lot. Please leave a comment, click the like button, so that every time, so I can keep on making the video like this, you know what I'm saying. So thanks a lot for your time, man, and leave a comment, tell me what you think. Okay, if if I can get a lot of feedback, I'm gonna do a lot of questions like this non-stop for hours. Okay, peace, thank you so much, we out. Easy, man. Easy, man. Easy, man.